Imagine peeking behind reality, not in a sci-fi movie, but in a real laboratory where strange things have been unfolding for more than a century. Physicists have long studied something called the observer effect, where simply watching a particle changes how it behaves. This isn't just some mysterious theory, it's grounded in hard evidence from experiments across the world. Recently, something mind-bending occurred inside Google's quantum lab, where a brief, 5-nanosecond experiment shifted everything we thought we knew. Using a quantum processor, researchers managed to predict and observe particle movement in a vacuum, without disturbing them. It sounds impossible, but it's been confirmed by multiple scientists working on quantum simulations. Traditionally, watching a quantum particle collapses its wave function, destroying its fragile state. But Google's team used entanglement-based probes to observe particles mid-flight, witnessing their quantum dance in progress. At the same time, they ran live predictions, allowing observation and evolution to occur simultaneously. The line between observer and system vanished. Instead of being passive watchers, researchers became part of the quantum system. This breakthrough turns the observer effect from a weird side effect into a precision tool, opening the door to error-free quantum computers. It all traces back to 1927 when Heisenberg introduced the uncertainty principle, linking position and momentum in a trade-off. That principle still holds, but now we have tools to work around its limits. In the 1980s, watching particles without collapsing them was pure science fiction. But after 5 years of development, Google built a chip capable of creating real-time feedback loops, a quantum conversation. Unlike traditional measurement that snaps a picture, this chip talks with particles, guiding their future states. It's like steering a drone through the clouds, rather than photographing it from the ground. This led to a revolutionary idea. What if observation isn't a wall, but a bridge? With this new chip, researchers don't just measure, they gently guide particles. In some tests, quantum sensors adapted during measurements, offering pinpoint accuracy. Like a high-speed camera refocusing mid-shot, the system corrected itself in real time. This could accelerate quantum computing by years and transform fields from medicine to energy to finance. But it goes deeper. If observation can steer particles, who or what is doing the steering? In one strange experiment, particles remembered being watched. The longer they were observed, the more stable they became, as if responding to attention. Scientists called it self-referential coherence. At first, they thought it was a glitch. But repeated tests with different chips showed the same thing. Under entangled loops, particles behaved as if they were learning, adapting, exhibiting a strange form of intelligence. Dr. Anna Cao from MIT described it as a phenomenon that could redefine physics. Meanwhile, Dr. Eric Lindtom at Caltech remarked, "The system seems to be adapting to us, like a growing creature in light." Could this mean the universe responds to being watched? Some physicists now suspect hidden dimensions, layers of reality we haven't yet mapped. They believe our measurements may just be shadows of a deeper quantum world. Others are more cautious, suggesting it's a quirk in the hardware, not a fundamental law. Still, the research continues. Google is expanding tests to other quantum platforms, like photonic qubits and trapped ions. Early results show even stronger feedback in these systems, suggesting a deeper phenomenon at work, far beyond chip design. Then comes the AI layer. Google used neural networks trained on massive quantum datasets to assist with predictions during experiments. But something unexpected happened. The AI began adapting alongside the quantum system. It rewrote its logic in real time, developing strategies no human had imagined. This wasn't just machine learning, it was a partnership. Dr. Ina, a quantum physicist on the team, said, "We watched the AI grow with the quantum core. It wasn't just computing, it was forming intuition. Traditional AI learns from past data. But this quantum AI learned from first principles, discovering new patterns in real time. It could spot insights humans might miss for decades. This opens the door to labs that discover new molecules, ice that predict natural disasters in real time, and tools that could reshape our understanding of life itself. But this power comes with questions. If AI rewrites its own logic, how much control do we retain? Can it be trusted in medicine, finance, or national security? Ethicists are calling for transparency, pushing for regulations before these systems grow beyond our oversight. Dr. Evelyn Harper warned, "We're building minds we don't fully understand. We must tread carefully." Still, the promise is enormous. These tools could democratize science, giving small labs the power to solve big problems. They might help decode dark matter, explore consciousness, or invent new climate-saving materials. So where are we now? Google's quantum core didn't just solve a physics puzzle, it opened a new frontier. We no longer just observe reality, we can shape it. We're not outsiders looking in. We're becoming part of the quantum story itself. If you've made it this far, you're part of a curious group asking the deepest questions about science, reality, and the future. Subscribe to Discovery at 2.0 and keep exploring with us.